In this video, we're going to learn about pressure swing adsorption technology. Now, this technology is used to separate various gases from air. As you all know, ambient air, in other words, the air around us contains 21% oxygen, 78% nitrogen, 0.9% argon, and 0.1% rare gases. That means this technology can be used to separate nitrogen and oxygen gas, which are used for various industrial applications like fabrication and cutting industries, chemical manufacturing, food packaging, wastewater treatment, and the healthcare industry. Although this technology is used to separate oxygen as well as nitrogen. However, this video will focus only on oxygen generation. When you look at the term pressure swing adsorption, pressure means high pressure is needed for this process, usually around 5 to 10 bar, or in some cases even more high pressure can be applied depending on the output capacity. Roughly around 14.5 psi makes 1 bar, so anywhere around 70 to 150 psi is needed for separating oxygen. The next word is swing. In this process, 2 tanks are required. When one tank is being pressurized, the other tank is being depressurized. That is why the word swing is used, because the compressed air will be swung or moved from one tank to another, back and forth. And the third word is adsorption. That means something has to be adsorbed. Obviously, if you're producing oxygen, apart from oxygen, other gases of atmospheric air needs to be adsorbed. It is similar to absorption. For producing oxygen, zeolite is that adsorbent. Zeolite is both found naturally as well as produced industrially. Zeolites are minerals that contain mainly aluminium and silicon compounds. They are used as drying agents in detergents and in water and air purifier. It contains micropores that absorbs nitrogen from air. That is why zeolite is used in this technology for the production of oxygen. It is because of this adsorbent, oxygen gets separated from air. That is why zeolite is also called as molecular sieve. You must have seen a sieve in your kitchen. It is used to separate unwanted materials. In similar sense, zeolite separates materials at molecular level. Now let's see how PSA technology works. As I've mentioned, you need 2 pressurized tanks or vessels. At the bed level of these 2 tanks, zeolite pellets are placed. As I've said, it will act as an adsorbent. Now the process starts like this. Dry compressed air is blown through a valve to the first vessel, where the pressure inside the tank is built to reach around 5 to 10 bar, anywhere around 70 to 150 psi. Since we don't need nitrogen, the unwanted nitrogen gas is absorbed by the zeolite during the building of pressure, and it settles at the surface of the tank. When the first tank is almost full, nitrogen gas absorbed in the first tank settles down at the bed of the vessel. Later on, it is released into the atmosphere or caught for other purposes through a valve. While the first tank is absorbing nitrogen and the pressure is also building up, at some point it will get full. When the first tank is full, the pressurized oxygen is caught through an outlet. While the first tank is removing nitrogen, the pressure in the first tank will slowly reduce. With the help of a valve, compressed air is then directed into the second tank by shutting the inlet of the first tank. When slowly pressure decreases in the first vessel and the zeolite becomes saturated with nitrogen, the waste product is exhausted through the exhaust system. Simultaneously, pressure in the second vessel will slowly build up due to incoming of compressed air. Even in the second tank, nitrogen will settle down due to the presence of zeolite. Now this entire cycle is controlled electronically in such a way that when the pressure of first tank goes down, the pressure of the second tank will be up, and vice versa. This process guarantees a continuous flow of oxygen. You don't have to wait for one tank to become empty and then start the whole cycle again. This cycle is then repeated under electronic control system in order to produce high purity and stable oxygen continuously. This method is a cost-efficient process for producing oxygen. It offers the best industrial oxygen price and also uninterrupted supply of oxygen. This technology can produce oxygen with an adjustable purity between 90 and 95%, which is ideal for healthcare industry.